Is the straight line we learned in school truly an absolute truth that governs every corner of the universe, or is it a human construct? The concept that a straight line is the shortest distance between 2 points seems like an unshakable and eternal law of nature. This is not just a mathematical puzzle, it is a profound philosophical question about how we, as humans, understand the structure of reality. At the heart of this inquiry stands Euclid, the ancient Greek mathematician who lived in 3rd century BCE Alexandria. He is the central figure. During his time in Alexandria, Euclid left behind the most influential mathematical work in history, a collection of 13 books titled The Elements. This work was more than a textbook. It was a grand intellectual experiment demonstrating how truths could be proven through the power of pure logic. And so, we must ask, is Euclid's straight line a fundamental truth of nature, or is it a logical assumption manufactured by the human mind? Before Euclid, mathematics was not a systematic academic discipline. Egyptians used geometry for practical tasks like measuring land after seasonal floods. In Babylon, mathematics was applied to astronomical calculations, but most of these methods relied on empirical experience and established custom. There were very few attempts to logically prove why a formula worked. Euclid changed this by seeking a foundation grounded entirely in logic. Euclid established a few basic assumptions and set out to prove every geometric truth from those starting points, a revolutionary approach in history. He began by defining fundamental concepts like the point, the line, and the plane, which served as the basic building blocks of his system. From these definitions, he established several axioms, self-evident truths that require no further proof to be accepted by the logical mind. Based on these few axioms, he logically derived hundreds of theorems, building a massive intellectual structure that resembled a magnificent architectural feat. The most famous principle in his geometry is the parallel postulate. It states that through a point outside a line, only one parallel line exists. For thousands of years, this postulate was accepted as an obvious truth. People believed straight lines and flat planes were the structure of the universe. However, a surprising and world-altering transformation occurred during the 19th century, challenging the very foundations of traditional geometry. Mathematicians Nikolai Lobachevsky and Janos Bolyai discovered that by changing the parallel postulate, an entirely different and valid geometry could be created. They explored a world where infinitely many parallel lines could pass through a single point, giving birth to what we now call non-Euclidean geometry. This discovery sent a massive shockwave through human thought. Geometry, believed to be an absolute truth for millennia, was revealed to be a choice. It became clear that Euclid's geometry was just one possible logical system among many. This realization fundamentally changed our perspective on truth. The story became even more fascinating when modern physics began to adopt these ideas. Albert Einstein entered the scene with a revolutionary theory. In the early 20th century, Einstein proposed that gravity actually curves the very fabric of space, leading to his theory of general relativity. General relativity describes a universe that does not follow the rules of flat geometry. In this framework, space is a curved and dynamic structure. The flat geometry we learn in school is not an absolute law that explains every situation in the universe. It has its distinct limits. Euclidean geometry is a model that works perfectly under specific conditions, but non-Euclidean geometry is required to describe the true nature of space. Despite these modern shifts, the monumental achievement of Euclid remains as significant as ever. He established how we explore truth through logic. His legacy is not just about mathematical formulas, but about the very method of seeking truth through systematic and rigorous logical structures. Euclidean geometry became the model for all human thought, influencing science, philosophy, and the very structure of modern academic discourse. The core message is profound. Truth is not just discovered, it is understood within the logical structures and frameworks we build to perceive it. What we believe to be true today may also be a system built upon a set of specific, hidden assumptions that we take for granted. The method of deriving conclusions from set premises became the foundation of modern reasoning and the primary tool for intellectual discovery. From this history, we can summarize 3 essential changes in how we should approach knowledge and the concept of truth in our lives. First, we must understand that the knowledge we take for granted is often built upon specific and sometimes hidden logical assumptions. Recognizing these foundations allows us to see the world with greater clarity and question whether our starting points are truly absolute. Second, we realize that truth is not a single fixed entity. It can be explored and understood from multiple, equally valid logical perspectives. Being open to different geometric and logical frameworks enriches our understanding of the universe and our place within its complex structure. Finally, we learn that understanding the world requires the ability to think logically and critically, rather than just gathering isolated pieces of information. It is the structure of our thought that gives meaning to the data we collect. Logic is the bridge between observation and true understanding. Euclid's ancient question continues to offer profound meaning to us today. Truth does not simply lie on a straight line, it is in our thinking. I hope this exploration has provided you with a new insight into your own way of thinking and how you perceive the truths around you. This channel is dedicated to rediscovering human wisdom through the lenses of history, philosophy, and the great intellectual journeys of our past. If this story helped broaden your perspective, please like and subscribe to support our journey of discovery and intellectual growth. I am always grateful for your support as we continue to explore the great stories of human intellect and the philosophy that shapes us. I wish you all the best on your own journey of thought and discovery. This is Dr. James Ko, thanking you for your time. For further inquiries or academic collaborations, please reach out via email. This video was brought to you by Jongmoon Ko, or James Ko. You can contact me at k9039198@gmail.com. Let us build a better future together through the power of wisdom and reason. I have authored several works including Adam Smith and Picasso, exploring the intersection of economics and the arts. Other works include The Final Game Between the US and China and What to Leave After Ashoka's Conquest, available now. To learn more, search for Euclid's Elements, non-Euclidean geometry, and the axiomatic method for deeper academic research. You can also explore Einstein general relativity, philosophy of geometry, and logical foundations to broaden your understanding. Stay connected with the global academic community by following these topics. Join the conversation on the geometry of truth. Together, we can continue to bridge the gap between ancient wisdom and our modern world. Thank you for your support. Thank you for watching. Intellectual growth is a lifelong journey. Until next time, keep questioning and keep thinking. This channel is dedicated to rediscovering human wisdom through the lenses of history and philosophy.